Hello friends, in this video I'd like to solve the following problem from the Indian European Girls Mathematical Olympiad Team Selection Test 2023, problem number 4. Let f and g be functions from the set of real numbers into itself, satisfying f of g of x plus y equals g of x plus y for all real numbers x and y. We wish to prove that either f is the identity function or g is periodic, but not both. Just exactly one of these options is true. So here are my hints. First, show that if our function f is the identity function, that the g is not periodic, which shows that both options cannot be true at the same time. And then, going back to our equation, first, set y to be z minus g of x, where z is any real number, to show that f of z equals g of x minus g of x plus z. And then let x be 0, y and z be arbitrary real numbers, and use the previous equality to show that g of y plus z equals g of y minus g of 0 plus z. And from there you should be able to show that either f is periodic, f is the identity function, or g is periodic. So give this problem a try, and I will see you in just a minute. Alright, so let's start with showing that if f is the identity function, then g is not periodic. So suppose that f equals the identity function. Well, then also I will mark this condition by asterisk. Then we have the following: g of x plus y equals g of x plus y. And let's now set, for example, x to be 0. And then we have the following: g of y equals y plus g of 0, which means that g is affine, and affine function cannot be periodic. G is affine, so g cannot be periodic. Because it's not constant, yes? Constant function is periodic, but this function is obviously not constant. So that's done. So now let's drop our assumption. We are not assuming anything. And now let's go back to our equation, and I will maybe set y to be z minus g of x. Maybe let's put a line, and now set y to be z minus g of x in our very first condition asterisk. Then it becomes the following. On the left hand side, we have f of y, and on the right hand side, we have g of x minus g of x, also not y but z, sorry about that, plus z. For every real numbers y and z, x and z, sorry. It's very important, and let's mark this condition triangle. Alright, and now let's do something different. Let's now consider f of, or rather, g of y plus z. G of y plus z, we know that by our equation asterisk, g of y plus z is the same thing as f of g of y plus z. How do I know it? I'm just using my very first functional equation, but instead of x and y, I'm putting y and z, and here we're putting y and z. So now we will use our condition triangle. we'll use our condition triangle because we have argument of a form f of something. F of something. F of something can be replaced by g of, for example, I will put 0 minus g of 0 plus our argument. I'm using condition triangle here with x equals 0. All right, and now, so maybe let's write it below. We have established that for every real numbers y and z, g of y plus z equals g of y minus g of 0 plus z, and let's call, or maybe let's now change. Let's change, I wish only z on the left hand side, so let's change z to z minus y. And then we have the following. For every real numbers y and z, g of y or g of z equals g of y minus g of 0 plus z. All right. And now we have two options. Let's concentrate on this part, on this expression right here. Either it is 0 for every real number y, or it is not. So we have two cases. Case number one, g of y minus g0 is not 0 for some real number y. But notice that means that our function g is periodic, because this number can be called then t, and we have g of z equals g of z plus t. So then g is periodic with period t equal to g of y minus g of 0. So our function is periodic. Second case. Case number 2, well, says that g of y minus g of 0 equals 0 for every real number y. Now we should be able somehow to show that our function f is the identity function. How can we do it? Where is some equation for f? Oh, here it is. F of z equals g of x minus g of x plus z. Let's use it. It's condition triangle. By condition triangle, g of z equal, or rather f of z equals g of y minus g of y plus z. All right, but also maybe I will derive the formula for g. Actually, g of y equals y plus g of 0, so we can put it here. So we have g of y minus g of 0 plus z. So it's g of z minus g of 0. So it's z minus g of 0 plus g of 0, which is just z, which means that our function f is periodic. It is the identity function. F equals the identity function of real numbers. And that closes our proof. because in one case G is periodic, and in the other case F is the identity function. And at the beginning we have demonstrated that both of these facts cannot be true at the same time. And that closes our proof. So yes, very, very nice problem from India. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.